Hi everyone, it's Karishma here from MapleSoft, and today we're going to talk about trig identities, or proving them. And I know proving trig identities can be hard for some of you, but today I want to show you MapleLearn to make that task a little bit easier. So before we begin, the first thing you'll note is I've created a little trig identities cheat sheet that you'll see at the bottom of this video, as well as on the web page for this particular video. So take a look at it, download it. This will be your cheat sheet, and this will help you solve any trig identity problems that you may come across. In this first example, we're asked to prove the following identity, that tan of x times sine of x plus cos of x equals secant of x. Now, the first thing we're going to want to do is verify that this identity is in fact true. And we can do that by plotting the left-hand side and the right-hand side. Let's do that. X. So this is the plot of the left-hand side. Now we will plot the right-hand side. So this is the plot of the right-hand side. And notice how the two graphs lay one on top of each other. So these two expressions are equal. Now I want you to use the plot window as a way of making sure that any step you take in terms of either manipulating the equations or proving the identity, that your statements are always true. I'll show you what I mean. So in this particular example, we're going to go ahead and manipulate the left-hand side and show that the left-hand side is equal to the right-hand side. So step one is to go ahead and rewrite tan of x using the quotient identity. That we'll get sine of x over cos of x. You'll see as I've written this down, I get the plot of tan of x over here. So this is showing me right now that this particular expression is not equal or not equivalent to this. So I have sine of x over cos of x times sine of x, cos of x. So now they're the same. And now the second step is I want to rewrite the expression so the denominators are the same. So that will give me, here I'm going to multiply the top and bottom by cos of x. And I'm doing this so I can add these two fractions. Now I can rewrite this as sine squared of x plus cos squared all over cos of x. Again, so far so good. Everything is equal. So the next thing I want to do is apply this identity that states that sine squared of x plus cos squared of x equals 1. And if I do that, we'll get the expression 1 over cos of x. And 1 over cos of x, you'll recall, based on the reciprocal identity, is equal to secant x. And voila, we've proved that the left-hand side is equal to the right-hand side. Now, if that was a little bit too fast, I have a completed document here which outlines the steps that I showed in the video. So feel free to refer to this if you want to take a little bit of time to digest exactly what I've shown you today. This document, there's a link to it under the description in the YouTube video, as well as if you go to the MapleLearn website. In this next example, we want to prove that sine x to the power 4 minus cos x to the power 4 is equal to 2 sine squared x minus 1. Now, the first thing we want to do is actually verify that this is in fact true. So let's go ahead and plot this. We have sine x to the power 4 minus cos x to the power of 4. You can write them either way. So that's the plot. 2 sine squared x minus 1. And you'll see that this expression and this expression lie, the plots of those two expressions lie one on top of each other. So this identity is in fact true. So in this example, we're going to start by looking at the left-hand side. And I debated when I was trying to figure out how to solve this problem, to start with the left-hand side or the right-hand side. And one of the reasons I chose the left-hand side was because I noticed something on how I could factor this. If you recall a difference of squares rule, you can actually factor this and get something that I think is quite workable. So you'll want to recall the difference of square rule, which states that a squared minus b squared equals a minus b times a plus b. So here, let's start with the left-hand side, and we're going to now apply the difference of square rule. So you'll end up getting sine squared x minus cos squared x, this bracket, times sine squared x plus cos. Now here, I'm going to go ahead and apply this identity to this to simplify this expression or this term. If I do that, and next what I can do here, because the right-hand side is all in terms of sine, well, what I'm going to do is rewrite cos squared of x using this trig identity. So if I do that, I'll end up with sine squared of x minus 1 minus sine squared of x all times 1. And now this becomes you'll see over here 2 sine squared x minus 1. And once again, we've proven that the left-hand side is equal to the right-hand side. And as before, if this went a bit too quickly, I have a completed MapleLearn worksheet over here that you can refer to at your leisure. Now, if you're working on a trig identity problem and you're not quite sure how to approach it, feel free to leave me a comment in the YouTube channel. I'd be happy to take a look, and if I can help, create a little video and show you how you might want to approach it. Also, if there's other videos you'd like to see, other topics that you're struggling with, again, let me know. You can get in touch with me on our YouTube channel, or you can contact us at customerservice@maplesoft.com, and I'll be sure to get the message. And if I'm able to create a video or help you in any way, I'd be happy to do so. Thanks again for tuning in.